All right, so this is our bell work question for the day. We've got these lines square root of x, x minus 2, and the x-axis. We're rotating around the x-axis. So the question was, is it a disk or a washer? Dylan told us that he thinks it is both. He said from 0 until 2, on that portion right there, what can you say is true about the graph from 0 until 2? It's touching the line. It is flush up against the line. There is no space between our shaded region and the line we're revolving around. And then it changes because from 2 until 4, now it is not touching the line. There is a space in between from 2 to 4. Okay, there's a gap. And if there's a gap, it's going to be a washer. Okay, kind of a hard picture to understand in your mind what the shape's going to be when you rotate it. But think of it like this shape right here filled up and then a drill bit going about halfway down. Part of it is going to be completely filled, but part of it's going to be drilled out. That's what's getting us both a disc and a washer. So if we have two different things, which two answers do you think we could eliminate right from the start? A and B, because we have two different things, a disc and a washer. I need two separate intervals. One is going to go from 0 to 2. The other one's going to go 2 to 4. All right, let's look at the disc part first. The other reason I can tell it's a disc is I'm only rotating one line. Okay, I'm just rotating this one. So this would be my radius as I go around. We go from top line to bottom, top to bottom, top to bottom. So it is going to be square root of x minus 0. It's pi r squared. So square root of x squared is going to get me x. So pi 0 to 2 x. Both C and D are good for that first one. My second one is a washer. I can tell it's a washer because two separate lines are rotating around the line we're going against. Okay, we've got this line right here. That's going to be my big radius. That's going to be capital R because it's on the outside to the center. And this is going to be my little r because it's from the inside to the center. So we can factor a pi out. My big radius is going to be square root of x squared, big R squared, minus the little r. My little r here is going to be x minus 2 squared. Big R squared minus little r squared. It's pi for both of them, but we could just factor that pi out in front, and they did. So which one of these answers is correct? Is it C or D? It is C. Because if you look at D, they just took both things and they squared it. The square is in the wrong spot. We need to square each thing individually. Square root of x squared would just get me x, and then that thing squared, that's what I have there. Yes, ma'am? Nah, it wouldn't work like that. You would FOIL it. If you had that whole thing in parentheses like it is here, you would FOIL it, which would not get you the same thing. That's why we square each thing individually. Other questions here? Find the volume of the solid rotating around the line. 9 minus x squared. That's this guy right here. 9 minus x squared. And the line y equals 12. That's this line right here. We're revolving that shape around the line y equals 12 from 0 to 3. So 0 to 3 are my x values. So that's 0, that's 3, that's my shaded region. That is my shape, and I'm revolving it around the line y equals 12. That means I'm revolving it around that line. So show me with your finger, what's it going to look like when you revolve around that? How is it going to spin? This way, okay, a corkscrew, perpendicular to the x-axis. We're trying to find volume. How do you find volume? Integrate area. If we're going perpendicular to the x-axis, okay, that means you are drawing lines like this because we're going perpendicular to the x-axis. We're going to rotate that thing around. Eventually, it's going to get me that kind of cone shape right there. Is this problem a dx problem or a dy problem? Dx. Show me with your fingers. What do you think the bounds are if this is a dx problem? 0 to 3. Okay, make sure. The number one mistake students have made today is just forgetting, is it a dx or a dy? And that will really quickly tell you your bounds. Bounds are not hard if you make it dx or dy correctly and then you match that. It's a dx, so 0 and 3 are x values. Last thing we have to do is find the area. If I rotate that shape, is it around the line y equals 12? So around that line right there, is this thing going to be a disc or is it going to be a washer? It is a disk problem. I know it is a disk because the shaded region is completely flush up against the line I'm rotating around. Okay, it's touching it everywhere. There's no space. Okay, so this is a disk problem. It's a circle. So it is pi r squared. That's it, pi r squared. Cool. You can factor the pi out if you want, or you can just leave it right there. It doesn't really matter. It's not that difficult. All I need to do is figure out the radius of this circle. There's only going to be one because it's a disk. If there's two radius, then you know it's a washer. From where until where do I draw the radius? Top to bottom. What is the top? 12 is the top. Okay, because look at this shape. We went here to here. You got to go from the top. That's weird that we're starting in the middle, but in this case, that's the top line. Okay, so my starting value is 12. You are always, anytime we write a radius, always have to include the center. You can't find a radius without including the center of your circle. Okay, so we have to include that line that we're rotating around. So it's 12 minus, that's the top, minus the bottom. 9 minus x squared. What do you have to be careful with there? Parentheses. Okay, that's what goes right here because that's my radius. All I have to do now is plug it in. Now the issue here is you're going to screw up parentheses if you don't be careful. Try it real quick, see if you do or not. My suggestion, and especially after first period when we struggled with this is my radius, and that's really weird. And students are going to struggle because they're going to put the parenthesis or the square on the wrong thing. Okay, when you type in your calculator, last period I think I had like 6 kids put the square there instead on the outside. Count your parentheses when you write it on your paper and make sure you count the same when you type in your calculator. Or I think the easier thing is doing this. Okay, what I'm going to do first is I'm going to go to y1. And for y1, I'm going to type in my radius. So I'm going to go to y1 and I'm going to type in that radius of 12 minus parentheses 9 minus x squared. You don't have to do this, but it's going to make it way cleaner to type in here in a second. So once I've got that, then all I have to do is go pi. Well, I don't have to factor out the pi, I guess, but we will. I'll factor that pi out in front. Math 9. I'm integrating from 0 until 3. And then it's just pi r. And my r is really easy now. All I got to do is y1 squared dx. 407.150. It's way easier if you type it in as y1. You don't have to, but it's going to be a lot easier. You're not going to make the same parenthesis mistakes that other students will. Questions on the first one? Second one, same idea. We're finding the volume of the solid by rotating the line. 9 minus x squared, same thing. 9 minus x squared. And the line, y equals 12. Cool, that's the same line right here. About the line, y equals 15. That's this line. That's new. Y equals 15. I'm still on the interval from 0 to 3. And so my shaded region is still this guy from 0 to 3. That is my shape. That is my shaded region. I am revolving around the line y equals 15. This is the middle. That pink line there is the middle of my graph. So if I revolve around that line, show me with your finger, what's the revolution going to look like? This way. Which way am I perpendicular to when I revolve that way? Am I perpendicular to the x or the y? The x. This is a dx problem because I'm rotating this way. So this is a dx problem. How do you find volume? Integrating area. It's dx. My bounds are going to go from 0 to 3. All I need to do is figure out my area. Okay? If I'm revolving, it's one of two shapes. It's either a disc or a washer. Which one is it going to be on this problem? Washer. Why? Because there's a big old space here in between the shaded region and the line I'm rotating around. Okay, so this is a washer problem. To find the area of a washer, it is pi, big R squared, minus pi, little r squared. Big circle minus little circle. They both have a pi in it, so I could just factor out the pi. I'm going to put that pi out in front. And all I really need to do is figure out what my big radius is and figure out my little radius. To make my big radius, you're going to include the center line and the outside line. Okay, what is the furthest away from the center and the center? So obviously the middle here, the center, is going to be y equals 15. And I'm going to go from that line until where? the 9 minus x squared. So I'm going from there to there. That is big R. When I set it up, I'm going to use what one on top? The 15. Top minus bottom. Throw that in parentheses. That is my big radius. I went top line to the bottom, and always including the middle and always including the outside line when we're talking about the big radius. Then we're going to do the little radius. Show me with your fingers. What is the little radius going to be here? The little radius is just 3, okay, because we're going the middle to the inside line. It's just that little baby guy right there. It's just 15 minus 12, which you could do, or obviously just making that 3 is going to make it easier to type into your calculator. You take big R squared, throw that all in parentheses. See, I even screwed it up when I wrote it down right there. I did not put it all in parentheses. And then the little r squared, so minus 9. Type that into your calculator. Make sure you can get a value. Where 15 where? Like here? The 15 represents the middle of a circle. If I were to ask you to find the radius of a circle, do you need to know where the center is? Yeah. Absolutely. And since I'm revolving around the line 15, that is the center. Okay? Yesterday we didn't need that because we always revolved around an axis, which is 0. So we always said minus 0 yesterday. I think you asked me that same question yesterday. Okay? But in this case, we got to include the center because the center has moved. Again, you can type it in any way you want. I would suggest you type in y1 in right here. My radius, my big R. Well, my big radius went from 15 minus the inside line. The inside line was at 9 minus x squared. Close that parentheses. Okay? That is my inside line. 15, big, the center minus the outside line. So then when I type this in, I can put the pi out in front. Math 9. Math 9. I'm integrating from 0 until 3. Big radius, which is y1 squared, minus the little radius, which is 3 squared. It's really easy to type in. Big R squared minus little r squared. Get that phrase in your brain because don't type it in wrong. Big R squared minus little r squared. We type it in. We hit enter. We get 746.442. Questions there? Stay with me. We got 2 more problems for the year. Okay, 2 more notes problems in the entire year, and we'll be done. Find example 3. Find the volume of the solid formed by revolving the line y equals x squared and x equals 2 about the x-axis and the line x equals 5. Oh, and the x-axis about the line x equals 5. So I already drew it for you. Okay, this is x squared. This is x equals 2. And then obviously this is the the x-axis. That's my shaded region. We're revolving around the line y equals 5 or x equals 5. Show me with your arm, what does x equals 5 look like? X equals 5 is this vertical line. I know that's silly to make you show it since it's already drawn, but that's important. That is x equals 5. I'm rotating. Show me with your finger. How's this thing spinning? This way. I'm perpendicular to which axis when I spin around the line x equals 5? The y-axis. That makes this a dy problem. Show me with your fingers. What are the bounds of my shaded region going to be? The y values. So we're going from 0 until 4. All I have left to do is figure out the area. To find volume, we integrate the area. What is the shape going to be of my cross sections? Is this I'm rotating. So if I'm rotating, it's either a disc or a washer. What's it going to be on this one? It's a washer, and we can tell it's a washer because there is a space in between that. There are 2 lines being revolved, and there's a space in between the shaded region and the line I'm rotating around. So what is a washer problem? To find the area of the washer, it is pi big R squared minus pi of the little r squared. Big circle minus little circle. We can obviously factor out a pi. And so all I have left to do is figure out what my big R is and my little r. Talk for a second with your neighbor. See if you can figure out those 2 things. Be careful. It is a dy problem. All right, let's look at radii. Okay, I'm rotating this way. So when I make my radius, I'm including The big radius is the middle line and the outside line, the one furthest away from it. So what am I have to include here? 5. I have to include that line right there because that's what I'm rotating around. I'm going perpendicular to the y-axis, so I'm going right to left. So I'm going 5 minus that guy. That's the outside line. That's going to be my big R. So 5 minus, why am I not going to write 5 minus x squared? It is a dy problem, so the first thing I would have to do is get it in terms, get x by itself. It's going to be the square root of y equals x. That's this line. So it's 5 minus the square root of y. That is my big radius. I'm going to find my little radius. My little radius is including the middle line and the inside line. The inside function in this case is the 2. So my radius is going to be 3. You got to take the big R and square it. And you got to take the little r and square it, and you subtract it. Take out my pi, then it's 5 minus the square root of y squared. Don't do dumb things like say that's 25 minus y. Okay? Squaring it means you're foiling it. You don't want to foil it. Just type it in like that. Okay? Minus 3 squared. We could go ahead and say that's 9 or just leave it as 3 squared. That is my setup. All I have left to do is type it into my calculator. There's lots of ways to do that. I would do this. Go to y1. Type it in. We've got 5 minus the square root. I'm not going to use y. I'm using x. If we're typing in as y1, you don't want to use y there. So it's 5 minus the square root of x. That's my first one. Throw a pi on the outside. Math 9. I'm integrating that thing from 0 to 4. We're going big R squared, so I already have that typed in. It's y1 squared. Oh, no. Oh, no. Oh, no, 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 no. All right, there's that guy. Sorry. And then y1 squared minus my little r squared, which is 3 squared. Thumbs up, you got a number bigger than 60. Thumbs down, you got a number less than 60. We plug it in, we hit enter. You should have gotten 58.643. Check your work, see if you agree. Mix. So we just had this discussion. You can use the y's, but make sure you use the y's everywhere and not make one of them y's and one of them x's. Just be careful there. Okay, I always just go all to x. It's just easier to type in. Okay, example 4, find the volume of the solid revolving those two curves and y equals x about the line x equals 4. So obviously we need to draw first. Y equals 2 squared x. I'm not great at it, so I'm going to plug in some points. I plug in 0. I get 0. What else should I plug in? We could plug in 4. Square root of 4 is 2 times 2 would be 4. So at 4 we get 4. I could plug in 1. 1 square rooted would be 1 times 2 would be 2. So if I plug in 1, I get 2. And if I plugged in 9, I would get 6. There is that curve right there, kind of a teapot graph that's been stretched a little bit. I've got that thing and the line y equals x. So y equals x is pretty easy. It's that guy right there. It is the shaded region. This right here is my shaded region, that little sliver right there. And I'm rotating about the line x equals 4. Show me with your arm. What does x equals 4 look like? X equals 4. That's a vertical line. You are rotating around that line. Okay, that is the line I'm rotating around. Set it up, solve it, get an answer. Set us up here. Here we go. We are integrating. We are rotating it around this line. So I'm going perpendicular to the y-axis. This is a dy problem. My bounds are starting here at 0 and going up to 4 because they're y's. I am integrating area. And for this case, it is going to be a washer problem. I know it's a washer because there's a space all the time. Yeah, it touches right there, but it's just touching. It's not flat up against the line. Okay, so we don't need two integrals like we did in Bellwork. This is a washer. Okay, so we are taking pi, big R squared minus pi, little r squared. We can factor a pi out. My big radius always includes the center. So I'm including this line right here at 4, and I'm going to the outside line. That is my outside line, this guy right here. Now, the problem with that is I have to write it in terms of y. So I got to get y by itself. This is a place you could make a mistake. I have to divide by 2 and then square it. And so that right there, y over 2 squared. That square has to be on the inside there. That is what this green line is. So my big radius goes from the right line, which is 4. We started here and we went over to there. That is big R. 4 minus that line right there, which is that guy. Y over 2 squared. That is my big radius. Then I'm going to find my little radius. My little radius goes from the middle to the inside line. So my little r is 4 minus the inside line, which luckily for us is just y. Not anything too difficult. So if I were to write this down, you want to write it down because you're getting points on the AP exam, even if you just write it correctly, even if you can't type it into your calculator. You have to write it. If you don't write it down, then you won't get any points. That's big R. You got to take it and square it. Minus little r. You got to take the whole thing and square it. Lots of squares going on here. That's a place you're going to make a mistake. So we type this in, y1. My big R was 4 minus, and then parentheses, it was x over 2. Close those parentheses, and then square that whole thing. That's my big radius. My little radius was just 4 minus x, or you could do that as y's. It'll be fine. Everybody with me to there? That's big R and little r. That's what we just found. Look, that guy and that guy, same thing. Now that I've typed that in here, it should be really easy to type into my calculator. Pi on the outside. Math 9, 0 to 4. Big R squared minus little r squared dx. Enter. 40.212 is my answer. We are now done learning new material. Everything that's on the AP exam you now got in your brain. It's just up to us to make sure you understand when to use it and how to use it. Questions?